Hello everyone and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher Jen, and it's time for Wordplay Wednesday. We're going to talk about classifying igneous rocks via inside and outside. It'll make sense, I promise. So, last week we talked about one of the ways to classify igneous rocks, and it was by silica content. To review, those classifications were ultramafic, mafic, intermediate, and felsic. And we can narrow that down further by adding whether they are plutonic or volcanic. But what do those words mean? Plutonic igneous rocks are rocks that solidified beneath the Earth's surface. They are essentially crystallized magma, and they're often called intrusive igneous rocks. So lots of names for the same thing. These igneous rocks have large, well-formed crystals due to the slow cooling process of crystallization underground. And examples of plutonic igneous rocks include tonalite, syenite, diorite, peridotite, troctolite, granite, gabbro, and pegmatite. A lot of ites. And you can see in every one of these photographs they have very large, distinct crystals. You can tell that there are different types of minerals in these, and they are very obvious. There are many types of igneous intrusive structures that can form, including dikes, which is an intrusion that goes perpendicular to the bedding of the host rock. Here's a picture I took of a dike in the Grand Teton when I was visiting the Tetons one of the many times I went. You can have a sill, which is an intrusion that followed the bedding plane of the host rock. So where the arrows are, you can see there are two different basalt sills there in shell layers in Capitol Reef, it looks like. There are lopoliths, which are large concordant igneous intrusions with a depressed concave central region. Batholiths, which are a large exposed area of mostly continuous plutonic rock exceeding 100 square kilometers, or about 40 square miles. And you have stalks, which are small, irregular shaped intrusions that are exposed to the surface. So this is part of the Idaho batholith in Montana. This is kind of in between Butte and Bozeman. I've driven this highway a lot and climbed on the rocks and really wanted to explore more, but I'm always on my way somewhere else when I go through there. There will be more on this batholith next week. This here is a volcanic plug, so it's the solidified remains of a volcano's central pipe. This one is near Augusta, Montana. You can have laccoliths, which are lens-shaped intrusions that cause uplift in a dome shape. Here's one in Stillwater, or near Stillwater, Montana. Sensing a trend. I know a lot about Montana geology. That's what happens when you go to school there. Then we have volcanic rocks. So volcanic rocks are igneous rocks that solidify at the Earth's surface. They are crystallized lava, and they're often called extrusive igneous rocks. So just to recap, we have plutonic or intrusive igneous rocks, volcanic or extrusive igneous rocks, and boy, this green screen is doing funky things to my hands. Extrusive igneous rocks have much smaller crystals because they cool more rapidly due to contact with the Earth's atmosphere or surface water like the ocean. Some cool so rapidly that they lack proper crystal structure and they take on glassy structures. So some examples of volcanic rocks include basalt, andesite, rhyolite, scoria, pumice, and obsidian. Now, just like our intrusive igneous rocks, extrusive volcanic features exist, including lava flows, which are a stream or sheet of molten rock erupted from a volcano, like this basalt flow outside of Tres Piedras, New Mexico, or TP as the locals call it. It's where my grandparents are from, fun fact. Here's that same lava flow from the side as you take the highway through it. It's actually really cool. It's one of my favorite drives. It's actually part of the Taos Plateau volcanic field in the Rio Grande Rift Valley. Rio Grande. Anyway, which is a failed rift in North America, which is super cool. Here we have a rhyolite flow, so this is altered rhyolite, and this is in the Grand Canyon of the Yellowstone. So this is a rhyolitic lava flow versus the basaltic lava flow. And of course, because I have so many pictures of volcanic rocks for some reason, here's a recent basalt flow from Craters of the Moon, Idaho. And you can see just how flat everything is because the basalt literally took everything out in its path. Another volcanic feature are volcanic cones. These are a hill or mountain built up from volcanic material during eruptions. This one here is San Antonio Mountain, which is a dacite cone, or a dacite cone, dome. Anyway, however you want to say it, but it is a dome, not a cone. In northern New Mexico. So this is where those basalt flows were coming from, was from this volcano near my aunt's house. This is probably closer to what you imagine a volcanic cone to look like. This one's out by Idaho Falls. Another volcanic structure would be ash or pyroclastic flows, like this one here. Here's a picture I took of an ash flow in Yellowstone that's full of obsidian, and it's super cool. It's down one of the side roads that a lot of people don't take. And can I remember which side road that is off the top of my head? Absolutely not, but if you go through the west entrance, you'll find it, maybe. I know it's on that side. Another rather big feature are calderas, so places where volcanoes have kind of collapsed on themselves. This is the Yellowstone caldera, and this hill right here above my head, that is the edge of the caldera. It's quite impressive. It's a very large caldera. Another really large structure you can get for volcanic rocks is volcanic plateaus, or flood basalts, which are massive eruptions that cover a very large area. This here is in Hell's Canyon on the Oregon-Idaho border, and this is part of the Columbia River flood basalts, which cover a vast majority of Oregon and Washington. So, very impressive flood basalts. You can get fissures, which are linear cracks or vents through which lava, volcanic gases, and even pyroclastics can erupt from. This is a recent one opened up in Iceland. Then, of course, some familiar ones, geysers, which are hot springs in which water intermittently boils, sending water up into the air along with steam. Can have a lot of force behind it, like at Old Faithful. Sometimes they just kind of bubble and spew all the time, like this little one that's in that same sort of geyser field in Yellowstone as Old Faithful. And sometimes they don't boil, and you just get a hot spring, in which a natural spring that exists, and it has a temperature higher than 71 degrees Fahrenheit, or 21 degrees Celsius. This is Grand Prismatic. This was a cold day. Can you tell? It was very hard to see. So here's a better one from another day that I went, because I went to Yellowstone once a month when I lived up in Bozeman, because why not? It was right there. And one last feature to throw out there that you can see from the volcanic side of things are mud pots, which are formed by standing surface water that is acidic enough to dissolve surrounding rock into clay. And then you basically have boiling mud. And they stink. So do hot springs. I mean, there's so much sulfur gas, so many sulfur gases. They're just, it makes Yellowstone stink. These ones can make fun colors. That's why they're called the painted pots, because of the different rocks that do get dissolved, and then they make fun colors. Anyway, hope you got to learn a little bit about plutonic versus volcanic rocks, intrusive versus extrusive, and I certainly learned that I take lots of pictures of volcanic structures in my home country. So now you have new terminology to impress all your friends with. And I hope you tune in tomorrow to learn about a scientist who changed what we know about the interior of our planet. So, fossilized you later.